Every year, over 1.5 million new homes rise from the dirt across America. They begin as nothing more than blueprints and dreams. But behind every nail, beam, and brick lies a complex dance of engineering, labor, and design decisions that shape the way millions of Americans live. Most people will live their entire lives inside homes, without ever knowing what actually holds them up. Today, we're taking you inside the complete process of American housing construction, from the first shovel in the ground to the final brushstroke of paint. We'll uncover the why behind America's preferred methods, why we build with wood, how our codes protect or fail us, and what really makes an American home American. This is your ultimate guide, a full journey through American home construction, start to finish. Every home starts the same way, with dirt. And from dirt, a foundation. The foundation is the most permanent part of any home. It's what the entire structure depends on. Slab-on grade is the most common foundation in warm climates across the U.S. A single, thick slab of concrete is poured directly onto leveled soil. It's simple, fast, and cost-effective. This method keeps costs low by eliminating basements and crawl spaces, but offers minimal insulation from ground temperatures and no room for underfloor utilities. In colder regions, like the Midwest and Northeast, full basements are the norm. They offer valuable square footage, energy efficiency, and better frost protection. But they also increase construction time and cost by as much as 30%. A crawl space is a middle ground, cheaper than a full basement, but more flexible than a slab. These foundations are common in the south and coastal areas, especially where moisture or flooding are concerns. Proper ventilation is critical. Poorly maintained crawl spaces can attract mold, pests, and structural damage. Pier end beam, also called post end beam, lifts homes above the ground. Used in flood-prone regions like coastal Texas, they protect homes during hurricanes or rising waters. While more expensive up front, they can save homes and lives in extreme weather. One of the newest systems in residential construction is ICF, insulated concrete forms. These are hollow foam blocks stacked like bricks and filled with concrete. The result? Thick, insulated, energy-efficient walls. ICFs outperform traditional poured concrete in energy savings and disaster resistance. But their cost and learning curve limits widespread adoption. Each foundation type comes with trade-offs: cost, performance, regional compatibility, and longevity. What works in Florida won't work in Michigan, and what survives an earthquake may fail in a flood. Foundation decisions aren't just technical. They're environmental, geographic, and economic. Once the foundation is set, everything else begins to rise. Once the foundation is cured, the wood comes in, and with it, the framework for nearly every single-family home in America. Wood framing is fast, affordable, and forgiving. But that's not why it became dominant. To understand, we have to go back. This is balloon framing, popularized in the 1830s. Long vertical studs stretched 2 stories high, with floors hung off them. It was simple, cheap, and fast, but had a fatal flaw. It turned homes into vertical chimneys during fires. Today, we use platform framing. Each floor is built like a table, with fire stopping built in. Most American homes use 2x4s, but energy codes are pushing a shift to 2x6s. Why? More insulation, greater structural strength, and easier compliance with energy efficiency standards. You get a deeper cavity, and that means better thermal performance, especially in colder climates. Engineered lumber, like LVLs and I-joists, is changing how homes are built. Unlike solid wood, these components are precision-made. They span longer distances without sagging, resist warping, and use fewer trees. That's critical in open-concept floor plans and second-story spans. Stud spacing seems like a minor detail, but it directly affects insulation, material costs, and wall strength. 16 inches on center is standard, but 24 inches spacing is gaining traction in energy-efficient designs. It reduces thermal bridging and saves wood, but must be carefully engineered. Above every opening, whether it's a window or door, sits a header, a horizontal beam that carries the weight around the gap. At the base, sill plates anchor the home to the foundation. These are the unsung heroes of every wall, quietly holding everything together. Modern codes aren't just red tape. They're lessons written in blood and insurance claims. They ensure homes can withstand wind, snow, earthquakes, and fire. Each nail pattern, stud size, and hold-down bracket has a reason. And as climate threats grow, those codes evolve fast. Once the bones are in place, the house becomes something else. From this point forward, the frame is protected, and the pace accelerates. Single-family homes aren't the only way America builds. In cities, multifamily construction, apartments, and condos is the housing engine, and one design dominates them all. It's called 5/1. 5 stories of wood on top of 1 story of concrete. Why? It balances cost, height limits, and fire code restrictions. The concrete podium contains retail, parking, or lobby space. Everything above? Fast, cheap, code-compliant wood. Building codes cap wood frame height to reduce risk in case of fire. That's why 5/1 is so common. It hits the max height allowed under Type 3 and 5 construction. Fire codes also require firewalls between units, sprinkler systems, and rated stairwells. For taller or more open designs, builders may mix in steel and concrete, creating hybrid systems that blend cost and structural strength. You get the flexibility of steel without going full high-rise. Modular construction is changing the game. Entire apartment units are built off-site, delivered, and stacked like Lego. It slashes build time, improves quality control, and reduces waste, but it requires upfront precision, and the logistics are brutal. From Los Angeles to Boston, 5/1 buildings dominate because of code, cost, and speed, not design. This is the architecture of economics. Multifamily construction isn't glamorous, but it's what lets millions of Americans live in cities they otherwise couldn't afford. What makes a home livable isn't just walls and a roof. It's what's inside those walls that brings a home to life. Before drywall ever touches the wall, electricians lay the nerve system of the house. Every switch, outlet, and light fixture begins here. Modern homes require more power than ever. EV chargers, home offices, smart devices. Codes now demand arc fault breakers, GFCI outlets, and dedicated circuits for major appliances. Water in, water out. That's the job of a home's plumbing system. Hot and cold lines feed showers, sinks, and appliances. Drainage systems rely on gravity and venting. Newer homes favor PEX for flexibility and freeze resistance, replacing copper in many builds. Codes ensure separation between potable water and waste, and require venting to prevent sewer gas buildup. With the systems installed and inspected, the home gets its skin, drywall. It's fast, cheap, and durable, but good finishing is an art. Joint compound must be applied, sanded, and feathered perfectly to hide seams. The systems inside your walls are easy to overlook, but they're the difference between a house and a home. While the interior gets refined, the outside is being sealed, protected from wind, rain, sun, and time. House wrap is the home's raincoat. It stops water from entering, but lets vapor escape. Proper installation is crucial. One bad staple or backward flap, and water gets trapped. Siding isn't just aesthetic, it's armor. Vinyl is cheap and easy, but vulnerable to cracking and warping. Fiber cement, like hardy, is fire-resistant and durable. Brick veneer looks solid but isn't structural. It's a rain screen with airflow behind it. Each material changes the cost, durability, and look of the home. The roof keeps out the elements, and your energy bills in check. Asphalt shingles are the standard, but metal, tile, and even solar-integrated options are rising. Modern codes require roof venting, ice barriers, and wind resistance ratings. Windows and doors are massive leak points for air, water, and energy. Proper flashing, sealing, and insulation are essential. Today's windows often include double or triple panes with low-E coatings. Most people will live their lives without ever thinking about what holds up the ceiling above them, or how their water gets hot in seconds. But understanding how your home is built gives you power. As a homeowner, renter, builder, or buyer, the decisions made behind the walls determine safety, cost, comfort, and longevity. In our next video, we'll go global, exploring how homes are built in Europe and beyond, and why their methods might surprise you. Until then, look around your home and know there's a story in every stud, wire, and window.